some names I recognize on here. So hello to all my former CAP colleagues, and glad that I was able to join you tonight. So what I'm going to do is share my screen here and hope it works like it did the last time. And here we go. We'll go to presentation mode, and we need to go back up to the top slide again. But are we on the cover slide? Good.
Yep, we got you.
Awesome. All right, well, so this is going to be exciting, I hope. So we're doing a lot at Sinclair College in the UAS industry, not just in Dayton, but also nationally and internationally. And so for those of you that maybe have been tracking us or maybe haven't seen what we've been doing for the last few years, we got a lot going on. So I'm hoping that there can be some nice synergies with Civil Air Patrol again. So think about that maybe for the Q&A session or follow-ups. If you have interest, we can chat afterwards. So as Emma mentioned, so I'm the Executive Director and Chief Scientist for Unmanned Aerial Systems at Sinclair. I've been there in a director role since July of 2013, and prior to that, about 6.5 years in defense contracting in broader aerospace, so satellites, manned aircraft, and UAS. So I kind of took a lot of what I was doing in the defense industry and moved it to Sinclair. So if you're kind of wondering why is a community college doing the things we're going to be talking about, because that's what I knew how to do, and so that's what they do now. But as we're going through this, feel free to jump in and interrupt me if you have questions along the way, so you don't forget them. Also, just as some grounding, Sinclair is the oldest community college in the country. A lot of people from even in Dayton don't know that. It's from 1887, and we have about 30,000 credit students and about 14 to 15,000 non-credit individuals served a year. So it's a pretty large institution, and we have a national and international reach. So a little bit about the UAS programs first, and then I'm going to get into some applications that I thought were maybe particularly of interest to the audience here tonight. So firstly, introducing Sinclair's UAS programs. Of course, we do what you would expect that we do. Depending on where your screen is set up, on the right banner, you'll see curriculum and consulting, and we'll talk about that a little bit later. But that's what most people would expect the college does. Is we offer credit and non-credit instruction, credit all the way up through a Bachelor of Applied Science in UAS, and also one in professional aviation pilot track now. So if you've got cadets that are interested in that as a career path, there is a 4-year degree path now at Sinclair. And if you're in state, I believe you can get out of there with around $20,000 for the whole 4 years. So that's pretty good. Of course, we do consulting for industry, government, and other academic partners as well. The things that are in the other 4 banners, you may not assume that we do. One of those is applied research and development. And so I'm going to be giving you several examples of those in the chat tonight, but that's really not basic research. In a few cases, we've developed kind of foundational knowledge, but in most, we're integrating an existing or a prototype sensor or radio technology as examples into an unmanned aircraft or even a manned aircraft. A lot of cross-linking like that. And so I'll give you some examples as we move along. Integrated data analytics. Almost everything we're doing in the industry right now in UAS has been focused for the last decade or so on more remote sensing applications. So ISR, intelligence, surveillance, reconnaissance. And if you're collecting all that data, whether it be video or imagery, hyper or multispectral, EOIR, of course, you got CBRNE, which chemical, biological, nuclear, those types of things. Of course, acoustics, LIDARs, radars. Those are all things that we work with. And so you're collecting all that data. What are you going to do with it? You got to process the data into information from which you can make decisions. So we're doing things, again, you might assume that we wouldn't be doing. For example, we're on a contract right now to LIDAR scan, so use a light ranging system, a B-52 bomber out at Tinker Air Force Base as part of its re-engineering program. So we're doing that through the college. So that's pretty cool. Advanced simulation, of course, you have simulation for training, and you would expect that in the labs on campus. But we also have a lot that we do with what's called live virtual constructive. I'll narrate a little video about that later, so we'll explain what some of that is. But as we're doing our simulation and our integration work, we've connected nationally with our deployed ground and tactical ground control systems, mobile computers and workstations, or connected even internationally to Israel for training exercises. So I would say we have simulation, but it's also integrated with live operations most of the time. And then commercialization and civil application development. So that's where we either partner with industry or government to advance their integration of UAS or integrate a new technology, get it from research to market. The toxic algae bloom work we did with NASA would be part of that. So I'll touch a little bit on that later. But a lot going on there, including a UAS entrepreneur program, which we were funded from the NSF to produce. And we just awarded our first 3 student competition awardees, I guess. One of them got a $25,000 pool of cash from the Ohio Third Frontier Fund through the Entrepreneur Center in Dayton that they can use to help set up their business and get organized. And 2 others got $2,500 to basically get a little bit more mentoring to move their idea ahead. What's cool about that is a team just has to be comprised of at least 50% Sinclair students or alumni. So if you've got individuals maybe in your squadrons that have a aerospace or particularly UAS related business idea, get them in touch with us. We'll connect them with the students or the alumni, and there's nothing that says they can't be part of a team that proposes and obviously can get some funding for their ideas. So a lot going on there, and I'm just kind of touching on highlights today. So if you have a particular interest in any vertical, again, you can catch me offline or direct others to me. So a little bit about the center in Dayton. We have a lot of lab capabilities ranging from wind tunnels, metrology, various maintenance, including unmanned and manned aircraft. We have a full A&P mechanic program at Sinclair through a 2-year degree. For traditional aircraft maintenance, so airframe, power plant, and general ratings. Also an indoor engine testing lab, actually just ordering a new engine test stand for propellers. We're doing a project on an STTR with an adaptive corp, which their headquarters is in Minter and in Hudson. And so they are working with us to 3D print propeller blades for an Air Force Agility Prime project. And we're going to be determining, working with a Czech company, if those blades will perform at least at the standard of the COTS blades for some period of hours. And so I'm going to be running those on a test stand and determining thrust and how they wear and if there's cracking and fatigue and that kind of thing. So engine test. Sensors and avionics, of course, we'll talk a little bit about that later, but I kind of gave you a list of the different types of data that we deal with. So therefore we deal with all of those types of sensors as well. So including radar, we've worked with Ghost Wave out of Columbus for an Ohio Federal Research Network project doing airport collision avoidance. So on UAS and ground mounted radars. And I'll talk about ground aircraft radar here in a little bit. And then indoor flight training and testing, I'll show you what those facilities look like, manned and unmanned aircraft simulation, and then advanced additive manufacturing. Our additive manufacturing actually is fairly in depth. We have most of the various material types. So there's fused deposition modeling, stereolithography, laser sintering. Laser sintering is, in this case, a laser, 1,000-watt laser, melting a powder of steel together, but we could do aluminum if we did a retrofit. And we do composites, both with chop and layered composites. You can do Kevlar or regular composites. So that's in addition to our CNC machining lab, which again, these labs are dedicated to our UAS program. So they're separate from other labs on campus. So if we need to develop, say, a 3D printed wing section to test in the wind tunnel, or if you need to make a part that's for a research project for integration, like we had to for NASA for getting their sensor into our aircraft, or maybe something's not made anymore, we can fab those in our shop using our Haas CNC lathes and mills and our additive manufacturing capability. And I don't know if you can see the mouse, but that's kind of right here in the middle. So it says Add Tech and CNC. That's where we would do that next to the US specific lab. The bigger airplanes in the back there are manned aircraft. So you got a Hawker 125 and a kit helicopter and a twin avion conversion from a single. So they use those for the AMP mechanic school, but we also use them as a kind of analogous aircraft up for the larger UAS. This is a separate facility. 2014, 13, 14, I wrote a proposal to the state for capital funds. And so that allowed us to build out this facility, move our AMP school back, and then also build this building, which is our US Indoor Flying Pavilion. At the time, it was the only, it certainly is the first permanent indoor UAS flying facility, right? So if you purpose built, if you add enough caveats to it, it's the only one. So on West 5th Street in Dayton. But basically it's 40 feet tall, 3,200 square feet. And we do this not just for community events. You see in the bottom image or in the side images there, that's the Dayton Drone Users Group a couple of years ago. In the winter, they come in and fly because it's too cold outside. But we host a lot of camps, air camp, UAS camp. So, again, we'd be happy to collaborate on Civil Air Patrol activities coming through in any of the facilities, in any version of just, more of an outing to a multi-day event. Back some years ago, I think it was 2005, I ran an aviation career academy for Civil Air Patrol cadets over about 3-4 days on campus, and we went all over Dayton, and it was kind of the early version of what later kind of evolved into air camp with other people involved. And you could actually earn college credit from that. So again, if you have questions or ideas along that front, let me know. We can talk about that. This is the indoor flight range. Yes, it's the field house, but it was only used about 40% of the time. And so the president asked me, well, could you use it for indoor flying? I'm like, sure. Well, the 60% of the time it's not used is 2 a.m. on Sunday morning, so it's not as great as it seems. But we have done up to 10 aircraft at a time in there, very small fixed wings. It's 35,000 square feet by 25 feet tall. It's a GPS denied environment, although for both we have a GPS augmentation system, so we can at least emulate GPS constellations, if not augment, if we don't have an outdoor signal. And we actually had a major automotive manufacturer from Detroit, you can guess, come down, and they did their first personal air vehicle prototype test flights in our flight range, which was pretty exciting, but it was also rather terrifying because they didn't quite have the kinks worked out, and those nets aren't as solid as they look. Mobile tactical ground control stations. So these are deployable units that we use for operations. We use these for live virtual constructive simulators or telemetry from live flying systems, ingestion into our network. We've taken these to Colorado, Texas, North Dakota, North Carolina. I'm trying to think, Florida, Maryland, so all over the states. Doing on-site connections back into LVC exercises hosted here in Ohio. And of course, we can use them for operations as well. The trailer actually also has a refrigeration and freezer system and white and gray water for environmental studies work. So we had that put together. We actually designed these with a company here in Centerville because they didn't exist. So a lot of what we have was so early on that nobody made it. So we actually got to be involved in the design and the speccing of it. So we take a systems approach to UAS. This is just the 6 main segments of a UAS. The human element is the most important part. Most people think, well, it's unmanned. There's not a pilot on board, so therefore you don't need people in the loop. Well, actually, there's quite a bit of training that's involved, especially when you get up into the complex systems or the complex ConOps or concepts of operations, environments, and safety risk mitigation processes. So at our core, the college is still a training institution. So training is part of that, but there's also human performance capabilities that we have to consider. And so we've actually done analyses on that with the Air Force Research Labs, the 711th Human Performance Wing, and others in the government. So, but as you can see, I won't read all the bubbles, but most people tend to think about the aircraft. That's the most obvious part. They might think about the payload. In most cases, as I mentioned, that's a sensor, but we have started to get involved in cargo aircraft. And so That's going to tie in a lot with Agility Prime, which is an Air Force program out of AFWorks, AFRL. And also, if you're not familiar with it, the Ohio Department of Transportation runs a program called Fly Ohio, and they basically run the UAS programs in ODOT and broadly kind of influence UAS throughout the state. And so there's a lot going on. They just put a recharging pad in Springfield Beckley Airport for personal air vehicles like air taxis. There's a simulator going in over there for air taxi. We're part of the projects looking at how we're going to be integrating UAV people carriers, basically Uber Air, if you want to think about it like that, from Dayton to Columbus, Cincinnati, possibly eventually connecting to Indy, Cleveland. So that's coming. There's a smart corridor outside of Columbus that's on Route 33 that's working on it. So, you know, it's what I'm kind of saying that in the reference of this slide, that it's a system of systems. And as we get more complex in our systems, the communication data links, the backup systems, the command and control elements, launch and recovery, these all start to become even more important and complex. So training and education are imperative. As you look across the bottom, I keep those pictures because those were our first 4 COED aircraft certificates of authorization. We're the only way to fly some years ago. So you can see kind of where we started. I wasn't sure if we were going to have, you know, cadets, seniors, or some mix on the call. So just as a quick drive-by, a small UAS, this is called a Vireo. Originally was a BF Goodrich aircraft. This actually is the model of aircraft that we flew the first beyond visual line of sight flights for the Air Force Research Lab in Ohio. That was Sinclair, and this is the aircraft type that we flew. So you can kind of see how the wings, this is a come off, the battery comes out, the payload comes out. This is a hand-launched Kevlar framed aircraft. So it's quite robust. It's very, very durable. This is a Lockheed Martin Indigo. This is another aircraft that we've had for some time, but I keep the images because they're pretty well labeled and you can make everything out on them. So this is a vertical takeoff and landing quadcopter. Now, what's the difference between you know, these and what you might be buying today? Well, when we bought this was about a $75,000 aircraft, and part of that was it had Lockheed. But the sensors on it by today's standards are horrible. I mean, it's you know, 320 you know, p cameras, really bad infrared video downlink, and you can basically, other than the flight duration, this was about a 45-50-minute flight duration, you basically can replicate something like this for well less than $1,000 in terms of performance today, and they're getting there on the flight duration. So, but it's a pretty good label of how all that goes together. So Sinclair has about 350 UAS. Now those range from small stim trainers all the way up through big systems. When I say big systems, I'm talking still sub 55-pound Part 107, if you're thinking about the FAR. We do have some larger than that, but we don't fly those at this point just because of the regulatory and the logistics in considerations. But we've been flying for a long time. Of course, I mentioned modeling and simulation. The images across the bottom of the screen, on the left, we have a 6 degree of freedom pneumatic motion queuing seat that was actually designed by an Apollo engineer, which is pretty cool. And so that's a one of a kind, came out of a CRADA program with AFRL. You can see our UAS simulation lab in the next image, virtual reality systems for visual landings of UAS. And then we have flight training devices, Redbird's GAT2, and then we have desktop PCATDs. So again, if anybody's got any interest in coming by, either for a tour or just to try stuff out, or you want to bring the squadrons through when things get a little bit better, we can put together any kind of activity set, anything ranging from just a tour to, you know, whole weekend events. So. Manufacturing and testing, I mentioned the additive and the CNC labs. What you see there in the right images, the top fixed wing aircraft is an Altavian F7200 Nova series, and the black blister kind of on the front of the fuselage there is a 3D printed housing that we co-designed and produced with NASA to integrate a 260 band hyperspectral sensor that then we flew over Lake Erie above Maumee Bay, Barberton Reservoir near Akron, Harsha, near Cincinnati, and we were looking at toxic algae blooms, which, if you've been tracking that, is a pretty big problem. So we flew that for 2 years directly with NASA. Actually, I started on the Nova Block 3, then the Nova Block 4 aircraft, and then the third year I had the sensor signed out to a company, part of that commercialization transfer work, Xylem Yellow Spring Sensors, and we flew a third year with them, and then also commercial off-the-shelf multispectral sensors looking at the same bodies of water. The right bottom image, that's an early image of a search and rescue payload that we developed for a response to Department of Homeland Security and the Israeli police department, for lack of a better term. So they have a collaborative funding mechanism called the Bird Foundation. It's a private foundation, but it's funded by both countries. And I'll talk a little bit about that more later, but you can kind of see that we leverage these facilities not just for education and learning how to operate the systems, but also for development of research projects. We actually think that probably this week we're going to find out that we're very confident we're getting a Digital Threads Award from the Air Force Research Lab. And the thread that we're going to be following in the manufacturing process is unmanned aircraft systems. So that's going to be leveraging all that. So we're the original equipment manufacturer for a lot of different aircraft manufacturers on the UAS side. Parrot is in Paris, Alistair is from Lyon in France, SenseFly and Flyability are Lausanne, Switzerland, Wingtrust Zurich, and then Altavian's Gainesville. They just got bought by FLIR. FLIR just got bought by Teledyne. So I'm not exactly sure where Altavian is at the moment, but I'll find out next week. And then Centera is up in Minnesota. So we are not just a domestic training partner. We have a lot of reach, particularly in Europe, but also in Israel, in addition to the US. Okay, so for those that are interested in the academic programs, we've got kind of way I put this together, you've got entry points. So each one of these short-term certificate programs are between 16 and 18 semester hours. And you can select a focus area, so precision ag, first responders, geospatial information systems, aerial sense data analytics. Any one of those will articulate up into a 1-year certificate. So we've already got a 1-year generic UAS certificate. We're adding a UAS entrepreneur track. Those then kind of collapse back in, whichever way you went, into a 2-year associate's degree in UAS, and then there's a 4-year Bachelor of Applied Science. So Sinclair had 2 of the first 4 bachelor degrees at community colleges in the state of Ohio. It actually took a legal change to let that happen. And it was one of the last things happening out of K6 administration. And so as I mentioned, UAS is one at Sinclair, the other is professional pilot, pro pilot track, right? So if anybody's interested in that, again, I can direct people to that, and it's quite a cost savings since we're a state college. So anyway, so we're a member of the FAA UAS Center of Excellence. We've been on there for 5 years doing grant-funded research for the FAA, primarily focusing around regulations and airspace integration. Right now, we're doing work on type certifications. We've done a little bit on human performance, also STEM outreach. This is something that I'd love to be able to do more of. We have a grant right now from the FAA to provide 120 outreach days with UAS lectures and hands-on simulation experiences. It was originally intended to be in 6th grade classrooms. We got through 19 days of it before the world shut down back in March. Since then, I've been given an accommodation to get out of the middle school world. And so we've been at a lot of museums that'll have us. Dayton History, so Carolyn Park and the Mound Museum, the National Park Service site out on West 3rd Street in Dayton, and we're getting ready to start some activities at the Air Force Museum in east of town. But if anybody's got any other museums that might be interested in their area, it's a statewide thing. So we were up in Cleveland actually the last week we were doing this at schools in March. Or we could even consider coming to a region, right? So if we wanted to have us come into Cleveland, Toledo, Columbus, whatever, and set up over a weekend and have squadrons come to us, we can do that. We can go to the squadrons. I've got a lot of latitude right now on how I can use those days. So we bring one of the mobile or tactical ground control stations. if social distancing is still a thing, we would bring laptops, set those up in a facility, one laptop per table, everybody's separated, everything's clean, everybody's wearing a mask. But it's a way to kind of get some engagement going on. So again, if there's interest, have whoever wants to be the point can get a hold of me and we can talk about that. We're a member of the National Science Foundation Center for Unmanned Aircraft Systems. So I've been the vice chair of that industry advisory board for 3 years. We're the only community college member. What's interesting is that CUAS has been around for about 8 years, and so it's about to be replaced with a new organization that we're proposing to the NSF called CAMS. I really don't remember the acronym, but it's the Center for Air Autonomy and Sensing, something like that. But anyway, so you can see the other universities that are members of the current center. So Brigham Young, Colorado, Boulder, Virginia Tech, University of Michigan, Texas A&M, and Penn State. So Sinclair has been invited to be the 7th research institution of the new center. So those would be our, in this case, peer organizations doing research for industry, which is subsidized by the National Science Foundation and paid for largely by industry member dues. So if anybody has an interest in research, again, let me know, cadets, seniors, whoever, there may be opportunities for collaboration through CUAS. We launched a podcast. It's called Autonomy Bites. It's a pun. But it is out there. So if pretty much it goes through every podcast distribution service that there is. So whatever you or your cadets might listen to, you can find it. Just search for Autonomy Bites. We have 3 episodes up so far. They come out monthly on the 22nd of each month. So it's pretty new. It's an interview format. It's about 10 minutes long. So it's not going to be a ton of time. You can even play it during a meeting. The first 3 episodes, first we interviewed Dr. Gregory Krutzinger, who has used UAS in response to wildfires in California the last few years, damage assessment work. We had an interview with Roy Peshin, who's the CTO of Simlot, which is a modeling and sim company that we work with out of Petah Tikva in Israel. And then the last interview was with Scott Korndike, who's the president of the Entrepreneur Center in Dayton, talking about opportunities for business development if you're interested in that. And the next episode is actually with a gentleman from up in Michigan talking about waterborne autonomy. So it's not all air, but that's a free resource out there. We also have the Journal of Unmanned Aerial Systems. So if you're looking for reading activities, aerospace related, this is open source, peer-reviewed online journal. We got 4 volumes out there right now. They're all, you can download individual articles. You can download the entire publication each time. We have both domestic and international articles have been accepted for publication. And the publishing board is Sinclair, Embry-Riddle, University of North Dakota, Florida, and I think I always get the last one wrong, so I have to look. Don't quote me. It might be Ohio State. So, but anyway, check that out, usjournal.org. And again, you get a hold of me if you don't remember how to find it, but if you just search for Journal of Unmanned Aerial Systems, you should find it. We didn't do a publication very recently. We were going to do one earlier this year. Obviously, things got away from everybody. So we're hoping to do a call for papers, I'll say this year, last year, call for papers this year. So as you heard, we have the Aviation Trail in Southwest Ohio. I've been on the board of that for about 5 years, but Sinclair as an institution is actually one of the Aviation Trail sites. And so as an aerospace kind of related event, if you visit 8 of the 17 trail sites that are part of the Wilbear Wright program, that's Wilbear Wright up there on the brochure, you get a free Wilbear Wright. And so you have 4 that you have to go to because they're required. So the National Park site with the Wright brothers, 4th Bicycle Shop as an example is one, the Air Force Museum is another, but you get some discretion in the other 4. And of course you can visit all 17, but it's a good way to get around the Southwest Ohio aviation site. So it goes all the way up to Wapakoneta and the Neil Armstrong Museum. It goes to Urbana and Champaign. It goes down to Cincinnati and the Tri-State Warbirds and the Butler County Air Museum. And it's mostly focused around Dayton. So, okay, so a little bit more broadly now, talking about applications of UAS. So these are just a few, and these are actually images from activities that Sinclair has done. So I'm not going to have time to go through everything we've done. These are just a few samples, and I'm not going to have time to go through any of these in any great depth. But just kind of going around the loop there, levees, dams, and water outfalls. We always try to work with a subject matter expert in the particular domain in which we're doing the research. So obviously, I am not a hydrologist. I don't make dams. I don't do water flow patterns. But when we're working with groups like this, we work, for example, with the Miami Conservancy District, which was formed after the 1913 Dayton floods, and they're responsible for the levee and dam network of Greater Dayton. And it's very complex. Actually, it's an interesting history if you look into how they figured out how to have the water breaks. They ended up using a lot of the technology from Dayton on the Panama Canal because they were contemporaneous. But anyway, so we did a lot of work inspecting the levee walls, the earthen dams, the concrete abutments, looking at concrete delamination, groundwater. There wasn't any seepage. I mean, the system was in good shape, but that's interesting work. Also working with the city of Dayton and Xylem, looking at water outfalls, even flying caged drones up into water outfalls. An outfall is basically a pipe that just lets water through the levee wall into the river system. So a lot of work there. You see the mines. That's actually a 3D model file from an orthomosaic processing. We came up with point clouds basically from aerial nadir shots. And so it looks like a side nadir image, but it's actually a model file. And that's a open pit mine in Vinton County. Roads and bridges, mines was with Ohio Department of Natural Resources and Ohio EPA. Roads and bridges, looking of course with ODOT, but we've done actually what I would call a book on this. 60, 70 pages or so on how do you use drones in terms of application of best practices and technologies to assess roads and bridges, as we did with airports. So we flew at sod fields like Waco Field in Troy. We flew at controlled airspace like at Wilmington Air Park, uncontrolled paved airports, kind of the whole range. We didn't fly in those 2 years in Charlie or Bravo, but again, it's a 60, 70 page kind of document. All of these have reports, but those two are larger reports with safety risk mitigation guides and tools that you can use. Again, if anybody's interested in that, get a hold of us and we will provide those at no charge because the state paid for them. So good resources. Power grid assessments, that started a couple of years ago working with Dayton Power and Light and then the Ohio Power groups. But basically now we're doing inspections for DP&L, looking at their power transmission network, right? So the transmission lines, not so much anymore with the substations, but mostly the power lines. And since September, our crews have flown over 400 miles of separate line mile inspections for DP&L as kind of a commercialization as an enhancement for the company. Environmental assessments. So there you see a dye release. That's the Ohio EPA guys putting the dye in the creek, not us. But they wanted to see how long they could visually track something resembling an oil sheen. We also did oil well pad assessments, looking at that with Gulfport Energy and the fracking sites. And then first responder applications, which I'll talk a little bit about more later, but particularly related to live virtual constructive integrations. One thing I don't have on here because it's not horribly interesting, but we're doing work with the manufacturers now on type certification. And it's a typical FAA process. It's a lot of paperwork, but once you're to the point of getting through the application period, you're doing hundreds to thousands of flight test hours on the topical airframe, right? So it's a pretty in-depth process. So I can't show you pictures of that though, because we have NDAs with the companies at this point on kind of where they are in the process. So looking at toxic algae blooms. Okay, so what I'm going to do, I'm going to play a video here in a second. But before I do that, rather than give you a bunch of slides on these, any one of these could be whole short courses. So we're just touching on a couple things. But this is the first year up at Maumee Bay. This is a dredging site peninsula off the Maumee River heading into Lake Erie. And so we were able to coordinate with the Port Authority up there for access. We coordinated with NASA on getting a 8-pound hyperspectral sensor that they'd flown on manned aircraft over the lake down into about a 4.4-pound box, and had to be redesigned. Got that into the aircraft. Of course, you have things like weight and balance, electromagnetic interference testing, all that kind of stuff. So we did our initial tests at Wilmington Air Park, and then here we are flying out at Maumee Bay. So remember I said we flew at a lot of different reservoirs and multiple years, so this is just an example. But here what we're going to see is
excuse me, ready for launch. Okay, ready for launch in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
So you can see it takes off with a pretty good rate of climb. It's pretty impressive because the aircraft was about 2 pounds over its manufacturer published payload gross weight. Of course, we worked with the OEMs to ensure that that was safe and everything was done correctly. And if you saw at the beginning of that video there, this little spit of road right there is what we had to land on as well. And so they would actually manually land once it would come around on an automated turn. And they had to, all their controls were backwards, and they had to put it down on this little strip of grass, because if they didn't, they'd scrape up the sensor cover. So anyway, so that's work up there with NASA. A little bit on beyond visual line of sight. So I'm going to actually play this video while I'm describing it. That's that Vireo that we were talking about. So this is a kind of an older system at this point. At this point, that aircraft was probably 8 years old. The reason we were flying it was because it had a Piccolo autopilot, and the Air Force Research Lab and the Airworthiness Office over there with Art Huber, they needed us to fly that type of autopilot because that's what integrated with their sky vision system. So there I am in slow motion, heroically throwing the aircraft and hoping it doesn't hit the ground, because this is about, was this Monday? I think the governor's press conference was going to be on Friday that week. And so we had to make this work. It was 13 days from Air Force calling the college to getting through the review board in that first flight. So we basically dropped everything and got through that process. So if you've ever done anything with Air Force Airworthiness Office, that's some kind of a record. So you have the government contractors there that are responsible for getting the SkyVision system integrated. What SkyVision does, it's a jointly funded project from the state of Ohio and the Air Force Research Lab, and it basically brings in the radar telemetry, the radar signal from 3 traditional aviation ground radar systems in Ohio. So, you know, the things we use for manned aircraft. It sends that data to a STARS radar scope. There's one in the truck. There's 2 in the truck. And then there's one that sits out with the pilot in command if they're not in the truck. That's generally the assumption. So we're able to view our telemetry from our UAS overlaid on that radar scope. So the regular air traffic controllers can't see where we are. It's not being fed into their system. We're basically taking their data, overlaying our data, but then it will tell us if we're going to have a potential conflict with a manned aircraft based on that coverage area. So what happens is the aircraft is launched from Springfield, Beckley. So this is a live airport. While we were flying, this is unsegregated airspace. There was no TFR. There was no special allowance for us to be out there other than the COA that the Air Force had been issued by the FAA. So a little bit of pressure because this is the first time anybody ever flown in it. And so you take off, you basically climb out to 1,000 feet AGL over the airport, and then you enter the floor of the BVLOS COA, Beyond Visual Line of Sight COA, which goes from 1,000 AGL to 10,000 MSL. And you then transit out into the airspace, which is 200 square miles. So it's quite large. And it's heading east out of Springfield, kind of towards Columbus. So that whole area is south of 70 is kind of where that is. But as you're kind of seeing everybody get set up here, you already saw the airplane launch. We'll let this go until we get to maybe the radar scope here in a second. But when ODOT made the video, this was a backup, kind of a marketing thing. But we flew on Monday, we flew on Wednesday, and then fortunately we were rained out on Friday when the governor and the lieutenant governor and the congressman and everybody came, because they wanted us to do this live again in front of all of them. And so we had the video, we got to claim victory. But let's see, we can skip ahead here a little bit. So you can see the mobile ground control stations, the red vehicle that we have, we were using LVC as a secondary visualization method. And then we were using ADS-B presentations as a tertiary method. So we had a lot of ways to know. And there's the star system. So you can see where the aircraft are moving around, and that's the feed coming in. And here we are leaving the visual line of sight COA. So you kind of get the idea there. So now that's a lot of integration work. But if you weren't aware of it, I kind of wanted to show you this and the HAB work and some of these other examples, because although Sinclair was integral to them, these are not things that are just Sinclair specific. These are state assets or things that are going on in the state of Ohio. And I think probably not everybody knows about them. You might, you're a different group than most, but you should probably keep your ear out, especially for ODOT. A lot of people don't know ODOT's doing that stuff. So tornado damage assessment, I'm sure everybody knows about the tornadoes that came through Dayton. What was interesting was Sinclair as an institution responded to that fairly aggressively. Our board allocated $750,000 for tornado response, even though none of our facilities were affected. What you see on the screen, I won't read the bullets, but these are just some of the the highlights from news reports about what some of the damage and injuries were. So we did a lot of UAS flights around the region from after the Memorial Day tornadoes for about a month and a half. And so, kind of putting on my CAP emergency responder hat, we were out there supporting the county engineers, the soil and water conservation groups, the parks districts, the city engineers. I mean, anyone you could think of that would be a consumer of aerial data, not just imagery. Originally, it was video and just shots like this that we were taking off Nadir from VTOLs. Eventually, we started getting to where things were getting cleaned up a little bit more, and we started doing orthomosaic mapping. And that was actually for comparative work. We actually had just about a month before that flown Wolf Creek from Brookville for about 3 miles, looking at the impact of the emerald ash borer and how ash trees had fallen over the Wolf Creek. And so we had a map, and that tornado went right down that creek. And so then we could fly it again and see how many more trees were in the creek. But this is along 75, about 2 miles, 3 miles north of downtown Dayton, where Sinclair's campus is. They had just put up this warehouse. They had to tear it down and rebuild it. They had just started renovating that hotel. They just raised it. This was a middle school over here. That's gone. This is on the other side of the interstate, kind of looking back, the hotel, and there's the interstate and that warehouse again. But while we're talking here, this was maybe 5 days in. This is around Neva Drive, Old North Dayton area, around Wagner Ford, if anybody's familiar with Dayton. And it was horrendous. I'm sure a lot of you were out there on response teams, or at least you may have been. And so we were out there in the field for a good hunk of June. Getting data. So it was pretty bad. But Sinclair had a lot of people out there, even doing debris removal and cutting down trees and all kinds of things. So proud to be part of a group that was volunteering like that. Okay, so live virtual constructive. So I'm actually going to play this video, and I'm not going to talk, since this video probably does a better job summarizing LVC than I could. This is about a 2-3 minute video, so we'll let this go, and then I'll kind of interject at the end. LVC
stands for live, virtual, and constructive. And what each of those mean is live are real people doing real things in the real world. So you might be outside flying a real unmanned aircraft system with telemetry or its location and time and space coming down to your ground controller. You might be broadcasting a video feed. You might be walking around in the environment with a cell phone broadcasting your location. Virtual are where you have real people doing simulated things. So you might be sitting at a simulation station operating a sensor feed from a virtual aircraft. And then constructive might be computer-generated actors that you really aren't controlling, but they can provide information to the scenario. Those three feeds really get put into a scenario environment and they appear as if they're all happening at the same time together. Our interest in LVC is for civil applications, and so first responder applications, infrastructure inspections, beyond line of sight, concepts of operation development, and things like that.
Sinclair's work in UAS, specifically around the live, virtual, and constructive, really helps to keep the region on the cutting edge of both UAS technology and UAS actual flight. So it's really an important piece of the puzzle in terms of how you establish, understand, and test potential commercial applications.
LVC is really attractive for training because it allows us to integrate more participants in a scenario more inexpensively. So you could have a lab of, say, 10 or up to 20 students sitting here in this simulator lab engaged with other students that are out in the field flying live aircraft. They could be connected to our mobile ground control vehicle, so you could have additional operators there. And in one of our prior exercises, we actually had participants connected to our LVC exercise participating live from Israel.
Every organization running a similar system can potentially participate in an LVC exercise. So not only making all those pieces play together, but also the application that they're playing on, like search and rescue, inspections, and other important civil applications.
With LVC, you're not just simulating the inputs to a flight controller and measuring its outputs, you're simulating the entire operational environment, vehicle, human, airspace, social, and other intangible measures that go into the complexity that is flying an aircraft in the national airspace system.
Working with Altavian and Simlot, we were able to develop a simulator for the ground control station of the Altavian's flight control system. And so you can sit in our simulator lab, in our mobile ground control vehicle, or anywhere that software is installed, and run in simulator mode just as if you were sitting at the real ground control station, leveraging the Simlot software. So it's our plan in the future to be able to do that remotely, so you can log in through the internet, and then be able to work through your ground planning and a lot of your con-ops before you ever show up to the airplane, save you time on site and make it much more effective while you're there.
Okay, so as I said, that's just a quick idea of what LVC is. We've done all kinds of scenarios, tornado response, active shooter. We've done work with missing person searches. And these involve live law enforcement and other organizations. So if that's something that anyone in Ohio Wing would like to participate in, we'd welcome that. Also, we're coming out this year with a thing that's called LVC Viewer, and that'll operate through a web browser. And so you don't even have to have the software, Simlot software installed or have the computer specs that you normally would to participate. You'll be able to see 4-dimensional weather visualization, so 3D plus time. Actually, from some of my research, integrated in video feeds from virtual and live aircraft flights, manned aircraft operations. If you wanted to have the CAP Cessnas be part of one of the scenarios, you could be either participatory or non-participatory traffic. But I would imagine we'd be doing joint search and rescue activities. And particularly if we can leverage the airspace out at Springfield, then AFRL is interested because that gives them data to test. So I know I don't have time to really do much more of a sales pitch on LVC, but if anybody at all from the SAR side or the aerospace side is interested, we should talk about LVC. Also related to search and rescue, we did a project we just wrapped up on officially on the research side with Simlot out of Israel. You saw Roy Peshin on the video there, and that was meeting a DHS and Israeli requirement for a search and rescue integration. And so we call it SPECTO. It's kind of from Latin, so watching. And so basically it allows you to both do mission planning and control multiple assets at the same time. but also these aren't just drones. You could be having ingest from ground vehicles, foot, search and rescue teams, drones, helicopters, whatever you have. But you can ingest all of that into a GUI. And so here's just kind of East Dayton, and you see the Metro Park up there. And so this is kind of a faux scenario we put together. But the big news from my side of it was we developed a payload. And so what you see there is a winch droppable, platform agnostic. So as long as it can carry the weight and the legs are long enough, it's agnostic. So the payload's about 7.25 pounds. But on the left here, this is a Selectech EH8X HL. You gotta name it as something else, but that's an octocopter, quad-armed octocopter made in Springfield, Ohio. And so we've worked with them for years, and that's the payload hanging below it there. And then this is a DJI M600 Pro, and this is the payload extended on a winch, and the winch is inside of the payload. So within the payload, you have a nadir camera, so that's giving you a downward sense of what's under the payload as you're raising and recovering, or if you're wanting to talk to a disaster victim. These two kind of ears on the side of it are auto-retracting, unpowered reels that keeps it from spinning. Because if you only have one, it spins really fast. If you have two, eventually they cross at about 20 feet. We can extend this to 40 feet, doesn't spin, it's real solid. Had to design all this, 3D printed it, got it all integrated. The payload power and winch is all in the payload. So you're basically just hooking it onto the aircraft and you're good to go. What we're gonna do here, we're going to play a little video. This is an earlier version. You can see it's only got the 2 lines and it doesn't have the ears on it there with those secondary winches. But this is to kind of give you an idea of what the two-way voice communication. This is kind of a big deal because there are not two-way voice communication systems for drones at this point.
Montgomery County Fairgrounds. I think I'm okay. It's pretty hot out today, though. How warm is it? Wow, 90 degrees is pretty warm. I'm actually kind of thirsty. Do you have any water? We will send somebody to your location with water. Okay, where you are.
Okay, so obviously you see it swinging and swaying. So we got all that worked out with those other winches, and it's a little noisy on this because it's basically being recorded off of a cell phone camera. So it actually sounds better than that if you're really there in person. But the point is, you can have a conversation with somebody at some distance. Maybe they're trapped on the roof, maybe they're across a swollen river, whatever it is, search and rescue, victim, whoever, maybe somebody injured. This was developed this way. Actually, we redesigned the whole thing this year because the Israelis were interested in using it for deployments for COVID quarantine neighborhoods to communicate with people. And this is, I think, my last video. So here you can see we're filming from an aircraft. This is the DJI, and what's happening here is the winch is actually raising the payload, and you can kind of see the distance getting shorter between the payload and the aircraft. It's not super fast, but we don't really want it to be. So that's that. So that's pretty cool. That wrapped up in December from about a 3.5-year project. It's going into commercialization and so forth now in Israel and in the US. So we're going to be looking at opportunities to get that rolled out to first users here in Ohio. So again, if you're interested or you know somebody is, let me know. And I left a few minutes for questions, knowing that it's almost 8 o'clock on a Tuesday night. So that is the talk for this evening.
Andrew, that was fantastic. Hey, I've got a question. So we had Dr. Matt McCrink from OSU into our conference earlier this year, actually, as one of our guest speakers. He's actually our keynote speaker for the banquet. Do you guys work with OSU much, and how have you guys collaborated? Yeah, we do. So I know Matt pretty well. Also, Dr. Jim Gregory and Jim Lawson, all those guys over there, and even in the farm side with Fulton and Scott Shear.
So we've worked with them a little bit on ag for the first 5 years of our academic summit. It was co-hosted with Ohio State. So this last year we hosted ourselves because they were busy with some other stuff, but that was fine. We actually are both on the FAA UAS Center of Excellence. So they're a core member. We're an affiliate. We just can't be a core member because we're not a university. And so we've collaborated on human performance research there. We've also done some, we did an LVC exercise that Don Scott connected in for Jim. He needed to do some demo flights. So yeah, I mean, kind of ad hoc as it comes up, but we're always looking for ways to work with Matt and Jim and the rest of the crew over there. Any other questions? You're all asleep. So.
Not hardly.
No, well, what I was hoping to do was just give you all a little bit of a taste about what we're doing. I was struggling this morning trying to decide what I even wanted to show because I had to narrow it down. If there's interest on any number of fronts, right? So if anybody wants to get a hold of us and talk about cadet education, we can do aerospace education stuff like I mentioned from the camps. On campus, we can come to you. We've got funding to come to you, so we can anywhere in the state. At least for the next year, I've got funding to go statewide with stuff. If you want to do search and rescue exercise training, LVC integration stuff, test the Specto payload system with us, anything like that related to EMS, we can do that. I would say, any thought you have, let us know, and we'll tell you if we can't. But we're always looking for opportunities to help out and get also learning opportunities for our students, right? So depending on how big of a project it is, they can get internship and capstone credits, and cadets or seniors can even get college credits from working with us. So
excellent. Yeah, we will definitely be reaching out to you.
Awesome. All right, well, any other questions? Well, thanks again for having me. Hopefully everybody enjoyed it, and I did. And nice to, I guess, virtually see some old friends. Hopefully it won't be another decade. And I appreciate being here.
Yeah, thank you so much for being here.
Yeah, thank you. All right, thanks everybody.
Have a good night, everyone.
Thank you very
Andrew,
much.
thanks.
It was a very good presentation. Appreciate it. We'll reach out to you.
Great, thank you.